Hey guys, welcome back. So today we're going to be looking at pixel sorting in TouchDesigner. So let's take a look at where we'll be going. So here we have our pixel sorting algorithm. We'll be able to use a threshold to control what is being sorted. We will learn how to have a couple different sort directions. For example, horizontal, diagonal, vertical. And we'll be doing all of this with some pretty simple GLSL, and although it will be potentially a bit new for some people, it should be pretty straightforward as far as the actual code, and I think it should be pretty easy to follow along. So, just to take a look before we get rid of all of this and start over, the structure of our project will be pretty simple. We have a feedback loop as the main effect, obviously be doing the actual sorting here. We have a couple inputs to our shader. We have our GLSL top that's doing most of the heavy lifting, and then just a little bit of post. I will also talk about what these guys are. This is just a little bit of infrastructure that makes our GLSL programming a little bit easier. And so before we get rid of everything, we can take a look at the kind of final output here. And it really does lead to a pretty nice effect. I really like it. And like I said, it's just so simple. It's a lot of fun. So with that said, let's get rid of all of this and jump into things. I will just keep my movie file, and we will start over with the rest. So, first things first, before we get into all of this, let's talk about what pixel sorting actually is, and a little bit of the algorithm that we're going to be implementing. So, there are some great resources on pixel sorting online. What I'm going to be showing you today is kind of an amalgamation, partially taken from ShaderToy. This okay, I guess ShaderToy doesn't work when I'm screen recording. Oh, it just took a while. So there's, I said, this ShaderToy demo that I use as a basis, as well as Cyphered, who, if you guys don't know, you should definitely check out, although it seems like his website may be down now. So maybe you can't check it out. But these are two resources that I use to create this effect. I'll drop the links in the description so you guys can follow along. And then the last relevant link will be some guy that I found online who had a very good description of the actual underlying algorithm that we'll be using. So I want to make sure that we have the link to that as well. That will be here. This guy, Tim Severian, I don't know, but he really goes through kind of his naive approach and then how he updated his approach to the algorithm that we'll actually be using, which is known as odd-even sorting. What odd-even sorting is simply a iterative approach. You can kind of see, if I zoom in here, a good visual example right here. By sorting in different directions, each frame or each sort step, it allows you to preserve information and have all of the pixels sorted cleanly without losing your colors. So I guess let's go to our sketchpad and talk a little bit about what's actually going on under the hood here. So here we go. Alright, so let's just imagine a simplistic case. Let's say we have 4 pixels. So we have pixel, 4 pixels, and each of our 4 pixels is just going to have a integer value. So in this case, let's just do something like 2, 1, 1, 4. And our task is going to be to sort this, and we're just going to do it horizontally since this is a one-dimensional array. So this will be frame 0, and then these will be our pixels. So what we're going to do is look at each pixel, each frame, decide for that specific pixel whether we're going to be comparing against the left or the right pixel from it. And then once we pick which comparison pixel, we'll compare the two using a comparison function that we can talk about and swap them. So our switching function is going to need to be dependent on both frame and the actual column of the pixel, because we don't want this, if I use a different color, we don't want our pixel 0 looking this way, and then having our pixel 1 also looking this way, and pixel 2 also looking this way, and pixel 3 also looking this way, because that will inevitably lead to information loss and a smearing effect visually, which we really don't like. So we want something more like this, where we have our sort direction alternating for our different columns. Columns because we're doing horizontally, but it would be rows if you're doing vertically. So we're going to compare pixel 0 looking this way. We're going to compare pixel 1 looking this way, so on and so forth. And that will allow us to neatly swap pixels without having our information loss. So I think maybe just like walking through this 4 pixel example would be kind of helpful. So I will erase these guys. Actually, erase these two. So if we define our sorting algorithm, or sorting direction, we will say, oh, whoa, long pen. We will say sort direction is going to be equal to, and because our frame is going to be increasing each frame, obviously, we can use that to help us alternate. So we want to be alternating based on the frame and then based on the pixels. So an easy way to do that will be to take the frame, add the pixel x location. So in our case, we'll just call that x, and then take the whole thing mod 2. And so that's going to return either a 0 or a 1. For example, frame 0, pixel 0, modulo 2, so that's 0 plus 0, mod 2 is 0, which means that our sort is going to be left. 1 mod 2 is 1, which means our sort will be right. So maybe we can just define this. We'll say 0 is defined as sort left, and 1 is sort right. So then 2 mod 2 is 0, and 3 mod 2 is 1. So we have our alternating sort directions, and that means that our next frame, frame 1, pixel 0 with a value of 2 is going to look left. There's nothing to the left. We'll have to address this in our code, but we definitely don't want that to switch since there's nothing to the left for it to switch with. So this is going to be just a 2. 1, that's going to be looking to the right where there's just another 1, so nothing to swap there. Same for this one, looking left, still another 1. And then finally 4 looking right. No change. So actually, we had no change in our sort based off of our first frame because of our initial directions. So now we're at frame 1 and calculating our sorts for frame 2. So we'll have 1 plus 0 is 1, mod 2 is 1, so that means we're going right for pixel 0 this time. And 1 plus 1, 2, mod 2 is 0, so we're going left, and then right, and then left. And so now our frame 2. So since our pixel 0 is actually looking to the right to compare, it's going to swap because, or sorry, rather, pixel 2 is looking to the right, or sorry, pixel 0 with a value of 2, looking to the right. It sees a 1, it is not going to swap. Pixel 1 is looking to the left. It sees a pixel with a value of 2, which is higher than 1, so it is going to swap. So 2 does not swap, but 1 does, and that means that we have a 1, and then a 2 here. Our pixel index 2 with a value of 1 looks to the right. It sees that there's a 4, so it does want to swap. The 4 does not want to swap with a 1, but that's fine because the 1 already swapped with it. So I guess the one thing to note is that this is a very simplistic case, and obviously in an actual shader, all of this is happening in parallel. So I'm doing this for illustration, but just know that all this is happening in parallel on your GPU. Cool. So now we can kind of see the dynamic. If our frame 3, or sorry, are using frame 2 to calculate for frame 3, 0 plus 3 mod 2, or sorry, 2 plus 0 mod 2 is 0, so we go back to sorting this way, and at this point it's pretty clear that our directions are simply going to be alternating every direction, or sorry, every frame. So I'm going to go a little bit faster through the rest of this. So then we have our 1, nothing happens, as expected. 2 is looking to the right, so it's going to want to swap the 4. 2, and then our 1. So this is step 3. Our step 4 will be, so just keep the direction straight, like this. Step 4 then has, so 1 looks right, 4 looks left. They switch because of the 4. 2 is looking left, 1 is looking, or sorry, right, 1 is looking left. And so that means that they don't switch at all, actually. So this will still be a 2, and this will still be a 1. And then our last frame, which will have the sort directions going this way, this will result in our 4 being here. This 1 and 2 are now going to want to flip. 2, 1, and 1. And so now you can see that we are sorted. Woohoo! Alright, so a bit of a trivial example, but I think it's helpful to get the intuition for what's actually going on here when we're flipping the sort directions each frame, and also by column. So hopefully that all makes sense, and at this point we can jump back to TouchDesigner and get started on the fun stuff. Alright, so first things first, just going to add a container. Add a null, collapse selected. We have our base. We'll call this pixel pixel sort, and we will dive inside. Alright, so move our null over here, and first thing that we will do is drop in a GLSL multi and wire in our input. Wire the input to the output, and we get our white screen as expected. Now, I think, let's get this over here and open up our code editor. Cool. Hopefully everyone can see that. Very good. Cool, so now we can kind of see what we are working with and get started. So, first things first, let's just get our color red in and start to see this. Cool. So, one of the first things we need to do is have a unit of measurement that will allow us to move one step to either the right or the left. And we want that unit of measurement to be a pixel width. So we can simply say vec2, we'll call it texel, and we'll say that the texel is going to be equal to the pixel width. Now, TouchDesigner has a really nice built-in uniform that will allow you to access the pixel width for any input by using that input's resolution. You can access that by using u, td, 2d, infos, and then index with the number of input that you want. So in our case, it's going to be input 0 dot res. Now, this is going to be a vec4, and the first two components, x, y, are going to be what we want. Those are going to be 1 over the resolution. So I guess we should make some notes. 2D, infos, 0.res. .xy. This really evaluates to something like GL fragcore.xy over res.xy, where res is the resolution of the input. Nope, that's not right. Sorry. It is like 1 divided by the resolution. And then the other components, the ZW components of the same vector, are just equal to the resolution. So this is helpful because this equivalence, this equals, only holds true if the resolution of our shader is the same as the resolution of our inputs. But sometimes you want to use inputs that are a different resolution from the shader that you're actually working with. And so it's a really handy trick to be able to basically just grab the input resolution for any of your inputs. So that is what we will do to grab our texel size. From there, we can set up our sort. So let's do it simple for now, and we'll say that our sort is going to be horizontal. Horizontal sort. So that means that we're going to want to sample pixels in 2 directions, horizontally to the left and horizontally to the right, as well as our actual live pixel. So I will say let's say this, vec4 image left equals texture, std, 2D inputs 0, and we will want our location, which is vuv.st, plus our texel, um, which is in this case going to be a very small number that's positive for both x and y, because it's going to be 1 over the resolution in both directions, times a vec2 of 1 and 0. So what this is doing is simply saying our left pixel is going to be equal to the first input, and we're going to sample that 1 unit to the there should be a minus 1 unit to the left of our current pixel. And it's left because we are subtracting this texel and then multiplying by the x component by 1 and the y component by 0. So that will create a vec2 with a so this will say then texel times vec2. This is going to evaluate to something like 0.0010. If the input 0 has a x res of 1000, for example. And that's because our actual texel is going to be something like this. 1, something like that. So when we multiply the x component by 1 and the y component by 0, we end up with this, which when we subtract from our current location is going to give us the pixel 0.001 UV coordinates to the left. Hopefully that makes sense. We will use our actual image. Will just be reading here from our current location, and then we will have our image right equal to, we'll just copy this and just add instead of subtract. So now we have our left, our right, and our actual samples. Don't actually need this. And we can just say image out. Awesome. So that's going well so far. Now we have our 2 samples, but we don't know which way to sort yet. So we need to implement this part of the algorithm in GLSL. So we need to take the frame and the column, modulo that by 2, and then use that as our sort direction. Now, the way that we'll do that is by adding a uniform called uFrame, set that equal to me.time.frame, add the uniform here in the shader, and then we can access it. So we'll say something like bool, because our sort direction is going to be either a 0 or a 1, so we can just make it a bool value. Sort direction equals, and then we will say mod uFrame. And so this is our frame. How do we get to the x? We need to access the glfragchord.x variable. We want to mod that by 2, and that's going to be either a 0 or a 1, right? And so then we can convert it to a bool by using a double equal sign and saying equals 0. So now sort dir will evaluate to true anywhere where there is a frame and column combination that leads to something modulo 2 equal to 0, and false otherwise. So that will alternate true false every frame and every column. Which is exactly what we did in our example before. Now we need to have something to compare, and we can't just compare the pixel values directly. We need to have some sort of summary measurement with which to do that. So a simple way to do it, and there are many ways, but a simple way to do that is just going to be taking the magnitude of the color. So we can say mag left, and we can just use the built-in GLSL length function. Image left. And I'll just repeat this for both of our other two samples, and that will give us our lengths. So we will convert samples to single measure for comparison. Could also use Luma any channel, etc. There's really many ways that you can sort. That is an entirely different conversation, but there's so many ways, and later on I will show you how to use luminance instead of pure color magnitude. Okay, so now we can sort. If sort direction, and because it's a bool, that's already just going to be true. If our sort direction, so this is really saying if sort dir is true, i.e. if frame col combo mod 2 is equal to 0. And in that case, what we want to do is have another conditional. So we're saying, this is defining our direction, so we're saying if we're sorting 0, which means looking left. If we're sorting left, then we want to say, if we're sorting left, and the magnitude of our left sample is greater than the magnitude of our current sample, then we want to set the value of our current sample to the left sample, i.e. swapping them, and that's it. If we're sorting the other direction, which we can just do with a simple else, we're just going to have a similar conditional, but it's just going to be looking the other direction. Alright. And then we're already outputting our image here, so that's great. Now we should just need to add some feedback and point the feedback to here. And there we have it. We can see that we are already starting to sort some pixels, which is pretty cool. Now, one thing we'll see if we pulse our feedback, and I'm actually, before I do this, just going to really quick parameterize this and make it equal to my hotkey. So that I can reset this. Cool. So we can see that we're only sorting in one direction actually, because, well, we can see that we're only sorting in one direction, which results in this kind of streaking, smearing, not very nicely sorted effect, which also is leading us to lose some colors. Now, the reason for that is because our bool sorter is actually evaluating to false in every case. And I believe that is because we need to cast this as an integer so that we can, whoops, we need to cast this as an integer. There we go. So that it can be appropriately compared to the 0. So it needs to be an int, otherwise this equivalence is always going to be 0. And now we can see that we are indeed sorting in both directions, as opposed to, if I take this out, just sorting in one direction. So, important to have that in there. And now things are going much more like we expect them to. Now, so one issue that we'll see here if we let this run for a while is that we're losing colors, things are going off the page, and we don't really want that, right? We want everything to be nicely contained so that we have a cool visual result at the end, not something that trends towards horizontal lines as we continue to let this run. So, the way that we will fix that is by adding a check in our sort and saying we actually don't want to sort if the sample that we're going to be switching it with is less than or equal to 0. So we can easily do that by saying and our length, and our mag left is greater than 0. And we want to do that here too. Mag right also greater than 0. Okay, I have a mistake in here that I just need to take a second to catch. That mistake is we need to be evaluating this comparison in opposite directions for our two left and right. Obviously, otherwise we will not have an actual sort going. So if we're looking left and we're evaluating if is the left bigger, we need to only swap if the right is going to be smaller. And that is now giving us the actual sorting effect that we're after. Which is pretty cool, and as you can see, pretty easy. It's relatively simple amount of code, and there's really nothing else going on here. We can throw a transform down just to give us a black background, but because we're not sorting, if this pixel values are 0, there shouldn't really be any alpha that's introduced unless there's alpha when you're starting. If there's alpha when you're starting, you probably do want this transform. But at a very high level, this is the basics. So from here, I'm going to clean things up a little bit, add some parameters to give you a bit more flexibility, and that will be about that. So what we can do from here is refactor this code just a little bit to make it a little bit more modular and input some functionality for different sorting directions. So let's do that. So what is the best way to start? The best way to start is going to be, well, let's just try and do it vertical. So we have our horizontal sort here. If we wanted to make this vertical, what would we have to do? One thing that we would have to do is switch this from a 1 0 to a 0 1. So now instead of this being like that, we are talking about this now. And the last thing that we have to do, so we'll see if we reset, nothing's happening, and that is because we need to also update the sort direction to change based on row and not on column. And we'll see that just like that, now we're sorting vertically. So the only things we need to change when we want to change our sort direction are the adjustments we're making to our texel, i.e. which way we're stepping, and the sort direction. So, to do that, let's do a little bit of renaming. And another thing that we're going to want to do is use a map for inputting our sort direction. Or sorry, not our sort direction, our step direction. So to do that, because I think it's helpful to see first, let's create a noise. Make monochrome off, 32-bit float, set it to something like 1024 by 1024, offset to 0, amplitude pretty low, like 0.24, make the period about 3, and that should be good. At our very, very top, very top here, we will then read that in by saying vec2, we'll call it velocity. Actually, let's call it step direction, and that's going to be equal to texture using our first input, our current lookup, which you can always get using vuv.st, and then we just want the R and G values. Although, actually, let's make it a vec3 and do the RGB values. The reason for the B will be apparent in a moment. So, read in step direction from texture. Cool. So this will allow us to do some pretty cool stuff. So, what we probably want to do is have something like a vec2 called step, and then have that step equal to texel times, in our current case, we're using this for vertical sort, and then step, I guess step is a reserved word, so we can say step step size. It's not totally quite right, but yeah, that's fine. Not totally size, because there's a directional component, but I don't think that really matters that much. We're still getting an error. Why are we still getting an error? Because that needs to be a vec2. Cool. And so now we can replace all of this just with our step size, which is handy. So now we can just change this from a 0, 1 to 1, 0. And if we change this to an X, then we're back to horizontal, which is awesome. But what happens if we change this to a 1? Then we start sorting diagonally. And this is where it gets somewhat interesting. You throw a -1 in, and all of a sudden we're diagonally sorting the other way. So the exercise is really figuring out a way to easily toggle between these, knowing that you also have to change your source sort direction depending on what your step direction is going to be. Now, to make this work with our velocity, we can do something like step size is equal to our texel times normalize, which is an inbuilt GLSL function. Normalize our stepdir.rg, so just the xy components of our step direction. And boom, we can now see that we are indeed sorting along the contours of this noise, which will be, I guess, a little bit more apparent with a lower period. which is pretty cool. So now we can see, yeah, that we're sorting kind of in the direction of our noise or velocity, which is pretty fun. And then, this alone is going to add a lot of just ways to play around. High exponent, low exponent, do a bunch of different things. And it's pretty easy to integrate, just like this. But as you can see, it's kind of difficult if you want to switch between horizontal or velocity driven or vertical. We have to change this line, right? Which I can move up here, but we still have to change this line. We still have to change this line, or at least comment it out, or not comment it out. And we will have to change this line. So it's 3 changes to change our sort direction, which is not super easy to do in GLSL, right? Like nobody wants to be in here changing all of this. So what we're going to do is set up a easy parameter at the component level, and that's going to allow us to do something cool with our GLSL and address this. So we're going to customize the parent component, give it a parameter called sort direction, and make that a menu. Now I'm just going to use numbers 1, 2, 3, 4 for my menu names. The names are going to be what the actual values that come out of the parameter are, and then our labels are going to be horizontal, vertical, diagonal up, diagonal down, and velocity. So we can now see that we have this cool drop-down menu, and if I put a parameter chop in here, we can see, point this to it, we can see that as our selection changes, the value associated here changes as well. Cut this, paste it down here, and point it at parent. Now, there are 2 ways that you could do what I'm about to do. You could either do something very simple and say, just make it a uniform, and just like literally drop this here and call this usorter. I'll do that for now because I think it's a bit easier. Actually, no, I'm not going to do it now. So this is the easy way, but it is not the performant way. And so the performant way is going to be to the reason that this would not be performant is because it would require us to have a bunch of if statements that are just going to be like, if sort direction is 0, then we're going to do this. If it's 1, then we'll do this. If statements are expensive for GLSL to evaluate, and we don't want to do any operations, especially stuff like texturing or sampling, which I guess we're not doing here, but regardless, we don't want to do any operations that we don't have to do. And so a better way to implement that same kind of if-else loop or if-else control flow is going to be to create a define statement, and that's how we're going to approach this. So it sounds harder than it is. We're simply going to take a chop to dat. We're going to convert this to text. I only want my sort direction, and all we need to do then is in here, before we convert to text, we want to insert 1 row before the first row, one column before the first column, and its contents are just going to be define just include names. That's actually much easier. So we'll just include names. We'll drop in a transpose, and then we'll do our define. Yeah, that's easy. Cool. And so then we have this, which we can make a null. And so now we basically just have a text dat. This text dat we can just point our shader to as a pre-process directive. And what that means basically is that all this code in this dat is just going to be added at compile time to our shader. So it's essentially just like we wrote this hashtag define sort direction 3 in our shader, but this allows us to parameterize it and add some functionality. So to show what's going on, I'll remove that and I'll just define it right in our shader. Define sort direction, just a space, no equal sign, and then we'll just do it 0 for now. Hashtag define is essentially just using text replacement, so anytime during compilation, anytime the compiler sees the text sort direction, it will simply replace it with whatever you tell it to here, and just inject that text. Pretty handy. Lots of uses. This is just one of them. The way that we will use that is by using hashtag if, as opposed to if like this. Hashtag if means that when the compiler is compiling this GLSL, it's going to be only compiling what's inside of these statements if the condition is true. So you can say if sort direction equals 0, then we want to take our texel, we want to multiply it by the one was horizontal, so we're going to multiply it by this. And then we want to set our sort direction to be based on the columns. And I'll just declare it up here, sortdir, so that I don't have to declare it here. And then we can just do end if, and that will end the entire and that will end this. So anything inside of these two lines is going to be executed during compile time and included only if this condition is true. So let's see what we got. Because our sort direction here is 0 and this is 0, all we need to do, it's still going diagonal because we're using step size here instead of texel, so we actually just want to do this. And then this should, yeah, okay, so now we're sorting horizontal because our sort direction is 0, and if we change this to a 1, we're not doing anything. Or we are still sorting and it's diagonal, but that's because of a bug that we're going to be fixing. So essentially, we can use this to define a bunch of different options for our sort, and those options will only add weight to our code if they're actually being used. So to add another, we want to get rid of this end if. We're going to make this an elif. Sort direction equals 1. We're going to make it vertical. As we mentioned, to make it vertical, we just need to do this, change that to a vec2 0, 1, change the direction to sort by rows, and that's pretty much it. So now we should see this working. That's great. We can do 2 more. And we'll make this 2 and 3. Diagonal up and diagonal down. So diagonal up, that will be nothing. We just don't have to do anything to Texel because we just multiply it by 1s. And then for this one, you just have to multiply it by 1 in one direction and -1 in the other direction. Which is negative, which is positive is up to you. Finally, this x or y, this can be either x or y for both of these diagonal sorts. Personal preference. You could also add some additional functionality to make this easy to change. I am not going to do that here though. And then last but not least, if we have our sort direction is 4, then we want to use the velocity map. And so to do that, we just want to grab this part from down here and multiply that. And then we have our end if. And so now, I believe, if we switch our... So now if we switch in here, we can see that switching the sort direction does indeed work across all of our different inputs. So now we only have to change one number, and we can parameterize that number by, again, using this preprocess directive. Although it looks like I need to remove this here if I'm going to define it there. Cool. And so now we can change the sort direction just from using this parameter dropdown, which is pretty cool. So the last thing that we need to add is a threshold for defining what pixels get sorted. So that will be pretty short, and we'll do it right now. Alright, so there are a couple ways that we could go about doing this, but the easiest one is just going to be adding a threshold and basically just evaluating that threshold. So we're going to add a uniform, we're going to add a parameter, call it sort threshold, that'll be a float. We'll add it to our vector page, parent.par.sort threshold.eval, sort threshold, that's why, sort threshold.eval, and then all we need is a function for luminance. We can't use length for this sort, or it's not as good to use length for the thresholding because this is a magnitude of a 4-component vector, which will be, depending on what bit depth and color space you're using, potentially a very large number. We want something that's going to be as close to the range 0 to 1 as possible, and so for that, I'm just going to use this function, CZM luminance. I got this from chapter 10 of graphic shaders. To be honest, I don't really know about the magic numbers, but I use it, and I'm going to be using it here. So I'll just drop this in the description as well. So we can just add this then as another condition to sorting. I'll just say and CZM luminance of image left is, and we'll want it to be probably greater than our sort threshold, which I don't think I've defined yet. So we did have that defined. We have an error, cesium luminance, no overload, and that's because we just want the RGB values here. Now I can just copy and paste this section, put it here, and just change this to right. And we need 2 ampersands here. And just so everyone knows, these 2 ampersands just mean and. So this is saying if this and this and this, then do whatever is inside. So we'll reset this and we'll see if our sort is working. Just pause. And now we can see that as we change the sort threshold, indeed our sorting is working. And we can still change the direction. So things are working pretty well. Now, if you were really trying to be precise, you'd probably clean up this naming. Instead of left and right, make it something like, I don't know, step direction and opposite step direction. Depends how nuanced everybody wants to get. I'm just going to leave these for purposes of this tutorial, but you probably do want to update them if you're worried about naming conventions. So I think this is going to be it for part 1 of this tutorial. I will probably do another one kind of exploring some additional ways to go with this, some other ways to use it, but I think this was a lot of material, and hopefully everybody will have plenty to explore and would love to see the results. So with that said, it's the end of today. Want to again thank everybody, and especially my Patreons. It's really just incredible support. Can't thank anybody enough, and we'll keep doing this as long as people keep supporting me. So thank you, and I will see everyone next time.